Welcome back to the powerhouse, folks, with your mathematical meathead himself. So, this was last night's homework. This right here, this follows up on all the topics we talked about relating to how to solve angle related problems, how to solve unknown related or unknown angles in angle problems, and not just with rays, but also with triangles. And on top of that, a little bit of 2D area sorts of problems. I'm going to scroll through the assignment real quick, then I'll roll through the answers real quick, and I'll explain problem by problem how to get the correct answer. So, here we go. Here's the first couple of questions here. Nothing too bad. One, two, three, four. I'll scroll through it real slow here. If you need to see it, once again, go ahead and pause the video. Okay, here we go. Boom. Now we're introducing variables. Yada, yada. Take a look. Take a gander here. Stepping up the difficulty. Oh, yeah, guys. Yeah, we ain't playing around when it comes to this stuff. Wow. Okay, yeah. Oh, all right. We got some triangles, okay? And then our favorite circles. So, that was what you got. Now, here's what it should look like. Here's the solutions. Here's the answers, right? Bam! Look at that. Whoa. All right, let's talk about this for a second. Okay, so this whole first page is all about recognizing, mostly, it's all about recognizing the appropriate angle relationship, and then based on the properties of that angle relationship, boom, you get your answer right here. This first one, right? We got here the B right here. We got a 71 in here. We got these two angles. They're inside the pair of parallel lines, which means they are, and there's parallel lines, so it means that they're alternate interior angles. Based on that property, we know that B, whatever B is, it's going to equal 71. So really no calculation involved. It's more of a recognition that B is, in fact, 71. Number two, recognize right away that this is a complementary angle, right? We have the little box shape going on here at the corner at the vertex there. We have so what it would mean is that this whole thing here and this whole thing here and all this, right? That itself is the angle, and you see here this other line separates that angle, two angles whose sum is 90 degrees. So whatever B is, we don't know yet, plus 44, both of that equals 90, right? Do some subtract 44, you get B equals 46. Some basic equation solving steps. Makes sense. 46, plug it back in, 46 plus 44. You work that out, that is indeed 90. Number three, once again, recognize the angle relationship. Recognize it as being B here, a number here. Recognize that these are vertical angles. Vertical angles, which means that you can kind of think of it, like I said, as a reflection, the opposites. So no calculation involved. B simply is 70. Life's good. Okay, another one here. We see our parallel lines once again. That should give us a bit of a clue that it would be either alternative interior or exterior. And so we see an unknown variable out here, outside of the parallel lines, right? Here they are, unknown variable outside of it, a number outside of it. They look visually the same, and of course we know based on the property of alternative exterior angles, they are in fact the same. No calculation necessary. Recognize B, in fact, is 38. Number 5, much like complementary, except it's actually supplementary. Supplementary, right, where we have an angle, in this case, the angle of a straight line, which is this line going up and down right here. This line here, straight up and down. That we know based on just geometric vocabulary that the angle of a straight line itself is 180 degrees. Right, so all of this space here 180. So we're saying that we're splitting this 180 up. We have a 53. We have a b, that's unknown. But we know that both of them combined have to equal 180. So we just set up an equation, b plus 153, work all the math out. Boom, b equals 27. b equals 27. Makes sense. 27 plus 153 is 180. Oh, life's good. Equation makes sense. Okay. Next one here. All right. Same ideas, but now instead of simply just a single variable, well, we're modifying those variables a little bit more, whether that be simply having multiple terms, such as here in number 6, or whether that means, even in you can kind of see in number 7, okay, multiplying that unknown variable by a term. So, anyways, recognize the way you should look at these problems, recognize the angle relationship first. That's what's going to give you the clue on how to set up your equations, right? So, boom, I've listed up here 6, I knew right away, supplementary, 7, alternative interior, 8, alternative exterior, 9, vertical. First, identify those. That's what's going to tell you what is going to equal what, or what needs to equal what. So, let's see, because these are supplementary, we know that this plus this here is going to have to equal 180. And you can see I've built my equation as such. It already gives me 128, so I got 128. I got to add x, and I got to add x plus 20. That's already there, right? So set it up. X plus 20 plus 128 equals 180. Combine the 20 and the 128, combine like terms, work all the math out. You get x is 32. You can see here that I've taken this 32 and I've plugged it right back in here, right back in. 32 plus 20 is 52. 52 plus 128, is that 180? Well, indeed it is. That's how I've laid it all out here. Very similar idea, number 7, except like I said, you're not adding a term to the x, you're multiplying the x by a scaling factor, which is 5x. So again, set these equal to each other. 5x equals the number of degree that was given, which is 130. Get the x by itself by dividing 5. X equals 26. Plug it back in. 26 times 5. Well, that indeed is, what? Is it 130? Yes, indeed, it's 130. Very similar idea, number 8. Very similar idea. It's exactly the same as far as equation setup and equation solving steps. Vertical angle, number 9. Same idea. Same idea. Recognize it's a vertical angle, which means that whatever is directly opposite of this 76 is equal to it. So 3x plus 1 equals 76. That's how I've set up the equation. You know, do a little algebra, right? Minus 1, divide 3, x equals 25. Okay, got a 25. Is that right? Well, let's plug it back in, right? 3 times 25 plus 1. I'm saying it's 76 if I did it right. The question is 76 equal to 76? Oh, yes, it is, boys. Yes, it is. Complementary, same idea with complementary, with supplementary, which was number 6. Recognize that because it's complementary, it's 90 degrees. So 90 degrees equals the two different angles added together. In this case, the two different angles added together, 42 and 2x. So here you see them added together. Do a little algebra to get the x by itself. Yada yada. X equals 24. Bam, plug that back in, as you see with the arrow. 2 times 24, I'm saying that's 48. Okay, so now I know this was already given to me, 42, 48. Let's see, do those add up and equal 90? Yep, they do. Okay, now we're moving on into triangles. Triangles, if you remember, Three angles. Try. It's in the word. Three. Try. Three angles. They all add up to 180 degrees. Again, you'll find out why later on in your math journeys, but know that that's simply true. So what that means is if you add up all three, they're going to equal 180. So the way you structure these sorts of problems, just put all the angles, make an equation where they're all adding together, equaling 180. As I've done here in number 11, you can see it gives us a question mark, but I've instead used the letter X. You can use whatever you want, but it is what it is. So I'm saying that this angle here, whatever it is, don't know it yet, plus this angle here, 88, plus this angle here, 39, all of that together equals 180, is what I'm saying when I write it out like this. Okay, now equation solving steps now. Time combine like terms. These two add up, give us 127. Get rid of the 127 on this side by subtracting. X equals 53. I'm hypothesizing that x equals 53. Is it right? Did I mess up? Well, let's see. If I basically replace this original x, this original question mark, if I replace it with what I got, 53, and then so 53, and then I still have my 88 and my 39, so 53 plus 88 and 39, is that 180? Well, you do the math on this, you add them all up, you will find out that they indeed do equals 180. Same exact, number 12 and 13 are the same exact steps, the same exact way of going about it. So I will skip talking about them with the idea that you can replicate the steps. Now these next series of problems are a little interesting. They may look a little funny at first. The steps are the same as what we just did here on these ones above, 11 through 13. The steps are the same. What's funny about it is that you'll see, wait a minute, like for example, number 14 here, right? I'm saying I'm adding this one up here, x plus 52 plus 48 plus 86, all that equaling 180. Well, if I'm doing the math, you'll see something a little strange here. X plus 186 equals 180, and then when I subtract it, I'm getting a negative number. That's funny to me. I can see how you would say that, but understand what you're doing by solving for x. You're not saying that the angle is negative or that it's 6 at all. In fact, you're just saying that there is a value. There is an unknown factor at play here with this particular angle. What we're saying here is that, so if we plug it in, we're saying that the angle isn't negative. What we're saying is the unknown factor at play is a subtraction of what it's giving us as 52. So 52 minus 6, or negative 6 plus 52. We work that out here as such. We're saying that angle is 46. 46. Okay, well that seems interesting. It's not a negative number, so that makes sense. We can see visually there's no way that can be negative. We're saying 46. Okay, well let's test out our hypothesis once again. Now instead of x plus 52, I'll just have my 46 here in its place. I still have these other two from before, which were given to us, and we're saying the whole thing equals 180. 180. Is that true? Work out the math. Yes, it is in fact true. It is in fact true. So 15, number 15, 16, and 17, both the same, exactly the same as far as steps are concerned. Not all of them end up being negative. You can see here, number 15, did the math. I got an x as a positive value. You still plug it back in to get a result. The actual answer of the angle, I should say, is, so for this whole angle, the problem's only asking you to solve for x, but the actual angle itself is 38. Right? I'm just asking you to solve for x for now. Again, same step, 16, 17. 16 came out to be a negative x number. Plug it back in, you work it all out, it ends up being 180 equals 180, true statement. Therefore, what you see is the steps we've taken, yeah, they make sense. 17 was a positive number, x equals 7, plug it back in, you get 47. You're saying 47 plus 81 plus 52 equals 180, right? So 47, instead of all that, just plain 47. Is it 180? Well, you add them all up. It isn't what it is 180. 180 is, in fact, equal to 180. It's a true statement. Therefore, the math checks out. And more of the same here. 18 and 19, more of the same. More of the same. Practice, practice, practice. Okay, we can't build up our mental muscles if we fail to pump over and over and over again. We got to get a good pump in. Work them mental muscles. All right, anyways. Now we're moving on to 2D area problems. The biggest, the biggest things probably that you haven't done before, but I really want to hit home here is that triangles, 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 right? The triangles can be represented in a diagram in several different ways. You can see 20 through 23, they are represented in a few different ways. But in the problems you're going to get on this, you got on this assignment, you're going to get on the quiz, it's going to give you your height, your base, and according to the formula here, the only variables, the only unknown variables are in fact base and height. So if you know all your variables, or you know all your factors, numbers, I mean, you know the values of all your factors, then you can get a final number answer, or in this case, final area answer. The biggest thing you got to recognize is what is the height, what is the base? Well, well. So let me explain that by looking at 23 first. That's the more intuitive one. A lot of students get that when they see a diagram such as 20 and 21, may not be as immediately obvious. So let me start with the discussion here on these two here, right? You got the big base here, saying 9 meters is the big base. I wrote here equals B. And the height, you can, the height. The height is it goes, it's a perpendicular line, or in other words, a line that directly hits another line at 90 degrees, which you see all these have the 90-degree symbol, but a perpendicular line that goes from one corner and it hits the base. One corner and it hits the base. As you see here, that has been done. And it's saying that it was 4.8 meters. Okay, so base, got that. Height, got that. Now you just replace the letters with the numbers that are given in the problem. So I for each one I started, I just wrote the formula. That's good practice. Good practice. I always recommend it, guys. In fact, on your quiz, if you don't put this, you will be marked off points. I need to see that you understand the equation, and I need to see that you are plugging in, you're substituting numbers for what are the variables. So here, 9 is the B, so that's why on this line here, B equals 9. Boom, right there. Height, right here, given to us, 4.8. Substitute that in. Okay, now do multiplication off on the side somewhere. For brevity's sake, know that it's 43.2. You can put it in a calculator. You can do the scratch pad math off on the side, like I said. You'll get 43.2. Multiplied, you can't forget this 1/2. 1/2 is very important. So we've talked about it before, why 1/2 is the way it is, why it's there. Again, accept the formula as truth. Accept that a formula is much like a cooking recipe. Accept that, you know, maybe you can throw in a little extra flavor, right? Throw in some vanilla where the recipe calls for chocolate. Throw in a little cinnamon where it calls for pumpkin spice. But a pie is a pie. A cake is a cake. The basic idea. And that's what a formula is, a recipe, right? So instead of chocolate, vanilla instead of 9. It could be something else, whatever, whatever, whatever. Anyways, plug them in. So when you have the 43.2, you're saying you're multiplying by 1/2. That's the same as dividing by 2. You do that, you get 21.6. Stepwise, calculation-wise, setup-wise, for all four of these problems, it's the same. It's the same. You just have to be able to to extract the appropriate information from the diagrams. Extract from the diagrams. Okay, there you go. You'll see. I don't think you'll see any diagrams that look wildly different from what you'll see here. You'll see some where the dotted line indicating the height is directly inside the drawing. You'll see that it has been extended outside the drawing on some. Beyond that, I don't believe you'll see anything different. So again, setup is the same, calculations are the same. The biggest thing is recognizing the diagram for what it's telling you things are, and then applying your knowledge of how to work a formula. Then, of course, our favorites. We've done this so many times now. Area of a circle. Area of a circle. Much like triangles, start out, write the formula. Best practice, write the formula. A equals pi r squared. R being the radius being from the center of a circle all the way a straight line to the edge of a circle, whatever that measurement is. In this case, 4 meters. In this case, 2 yards. Squaring means taking the radius 2 times, like 4 times 4, or in this case, 2 times 2, right? Twice, multiplying by itself twice. That's what the square means on the r being radius. Simply swap the r for the 4. Do the rough math here. You get 4 times 4 being 16. You still have the pi. I'm not going to make pi being 3.14 is the actual number that it is. I'm not going to make you, 16 times 3.14. You won't be doing that in higher level math. There's no need to do it here. So if you just leave it like this, 16 pi, I'll accept it. The more correct answer is to say it's 16 pi meters squared being the units. I'm not going to ding you if you don't have the units, though. The main point is I want you to understand what the formula is, how to use the formula to then come up with the correct answer. That's it, guys. That was the entire homework assignment. Nothing too bad. Angles, and then 2D area.